Let's take a look at scatter plots. Scatter plots are scattered points. So scatter plots are used to show how much two variables are related. The graph below is a study that was conducted on 147 people working in physically demanding jobs. And the scatter plot shows the relationship between grip strength, which is on the x-axis. So the x-axis is this axis right here, which is the horizontal axis. And it relates to the arm strength, which is the second variable, on the y-axis. And the y-axis is the vertical axis. So there we've introduced a little bit of vocabulary of a typical scatter plot. So each dot on a scatter plot, in this case, represents one person. So let's read off the information that it tells us about a specific person. So we'll take this dot right here. We draw a line straight down to the x-axis, and we see that it's between 40 and 60. If 50 is halfway in between, about here, so it looks about halfway between 50 and 60. So that point represents a grip strength of 50 pounds and a arm strength, draw back to the y-axis or the vertical axis, we see that it falls between 30 and 40, so approximately 35 is my estimate, 35 pounds. So this point, it represents a person. Let's give that person a name. Dave has a grip strength of 50 and an arm strength of 35. And that is very deliberately written in that order. The x or the horizontal axis always comes first, and the y coordinate or the y information always comes second. And this is called an ordered pair. The order matters, and it's a pair of information that relates to variables, grip strength and arm strength. Let's take a look at a second person. Try that skill one more time. Up here, if we draw a line straight down, it looks like that person, maybe we'll give it a name, Justin. He has a grip strength of 180 pounds and a arm strength of 120 pounds. So every dot represents a person. So let's take a look at some other characteristics that scatter plots have. Every scatter plot needs a title. This one's missing its title, so we're going to add it. It's the relationship between grip strength and arm strength. The axes have to be labeled, so labeled with the numbers on the scale, with the name of what you're measuring, and the units. So labeling means three things: units, numbers, and name. And the graph relates two variables. In this case, again, arm strength and grip strength. The graph has a trend, and you can tell that from this graph that if you have a large grip strength, you are probably going to have a large arm strength in general. If you have a low grip strength, you're going to have a lower arm strength. So that is a trend, and that trend has a direction. It goes upward from left to right. So that is called the direction. And in this particular graph, it would be positive or upward. A negative direction would have points that look like that, so a negative or a downward direction. The other thing that describes a scatter plot is the form. What shape do all the points make? Well, they're roughly up in a line. I know it's a bit of a stretch to say they're all in a straight line, but they are all moving upwards and it's in a relatively straight line, so that's called the linear form. If the dots were like this, you couldn't draw a linear as a straight line, it would be more of a curve. And we're going to talk about the difference between those things, but that's called the form, the shape that the dots make when you look at them as a group. The other descriptor is the strength. And the strength means how far apart the points are compared to the trend. So some of these points here are far away from the line. Some of them are very close. But in general, how close are they? The closer they are, the stronger the relationship. And you're going to learn about that in more detail in the next lesson. The other thing that describes a scatter plot are outliers. These are points that don't fit the trend. And this one is completely outside of the pattern, it looks like, so that can be considered an outlier. So every scatter plot has a x-axis and a y-axis. And when you are told to make a graph, you have to choose which variable goes on the x and which one goes on the y. And that decision isn't always straightforward, and that's what we're going to be practicing in this skill right here. So the independent variable is always on the x-axis, and the dependent is on the y. And that's because the x-axis controls the y variable. So the y variable depends on the x variable. So that's why the depend descriptor. So the independent is the x-axis and the dependent is the y-axis. And the x-axis controls the y-axis. So let's do that. Take a look at some examples here and just try and figure out which one would be on the x and which one would be on the y. So height and age. Does your height control the age, or does your age control your height? Well, I think hopefully it's a little bit obvious that in this case your age controls your height. If you're younger, your height is going to be shorter. As you get older, it's going to increase, flatten out it as an adult, and then maybe decrease a bit as when you become a senior citizen. So age controls your height. So that means age is the independent variable and height is the dependent variable. In the next example, if you've got questions on a test and you get a certain amount of them right, it's going to affect your test score. So the number of correct questions, controls the test score. It's not the other way around. So that means correct questions is the independent variable and the test score is the dependent. Now, as you know, when you drive a car, if you speed or drive quickly, then you're going to use more fuel, and if you use more fuel, it's going to cost you more to drive the car. So in this example, there are two variables. One is the speed of the car, and the other one is the cost of driving the car. Which one controls the other? So I think the speed of the car controls the cost. So that means the speed is the independent variable and the cost is the dependent variable. Measuring the temperature of the atmosphere as a function of time, or as years progress, it's the year that controls the temperature. The temperature does not have any effect on the year. So this is the independent variable, and this one is the dependent variable. Second to last example are stock prices. They vary, as we know, from day to day. That's what drives all the investors. And do stock prices have an effect on what day it is, or does the day have an effect on the stock price? I think it goes this way. So the day is the independent variable and the stock price is the dependent variable. And the last one is one that we've seen before. There's a relationship between arm strength and grip strength, and I think this one is a very difficult one to decide which one controls the other. If you have strong arms, will you have a strong grip? Does that control the arm strength control the grip strength, or is it vice versa? If you have a strong grip, does it control your arm strength? I think in this case it could go either way, and so that means that graphing it arm strength and grip strength could also be graphed grip strength versus arm strength, and this one is a bit ambivalent.